Hachures are a method for creating terrain maps that use short discontinuous lines that are drawn in the direction of the steepest slope. The thing that makes them look three-dimensional is the thickness of the line is going to vary with the slope value, and the thickness is also going to vary with the aspect direction and what we know about this illumination vector, which how those two directions, slope and aspect, align with an illumination direction so that we can change the line thicknesses accordingly. Let's take a look at some historic Hachures maps, talk about some automated methods here. So this shows from an article from 1800 how these Hachures worked. If we have steeper slope, we would put our black lines so close together that they basically fill up all of the area. But as the slope decreases, those Hachures lines get further and further apart. And we could also think of it if it's based on a contour framework. If the contours are a certain distance apart, this would be our line thickness. If the contours are closer, our line thickness would be thicker, and so forth. But we also have to remember that the line thickness is going to vary based on the aspect direction and how steep the slope is. So this is a famous series of maps, the Swiss Dufour maps from 1854, and these ones, although at first they look like they're just hill-shaded maps, they're actually representing the terrain by a series of short line strokes. So if we zoom in on one area, such as here, what we can see is that the 3D effect is really being made by just varying the thickness of these lines as we get into areas on the east side. Here's the ridge here. We're on the east side of the terrain here, which is more heavily shaded. And here we're on the west side of the terrain. It's more closely facing the illumination direction that's coming in this direction here, and these lines are thinner. We can also see that this one is based on the contour framework, and those lines are just being drawn between the contour lines in order to give this 3D effect. So how can we do this with GIS? Well, one simple way is just to start with a digital elevation model grid and convert our grid into points. And then each one of those points is aligned with the aspect direction, and the thickness, in this case of the arrows, is dependent on how steep the slope is. So we're accounting for both slope by how thick our arrow is, and we're showing direction by which direction the arrow is pointing. And then in this case, we're illuminating from the northeast here. So all of the arrows that are pointing towards the northeast or the north or the east are white, and all of the areas pointing towards the southwest or the west or the south are black. And we can see, once again, we put this on a gray background in order to clearly be able to see both the white and the black arrows together. And just like other maps like this, where this is pretty much creating a hill shading effect, even though it's doing it with short little lines instead of shading a grid, we can also add hypsometric tints, and this gives it a more three-dimensional effect. We're seeing the low valleys as green here, and then we're seeing the higher peaks go into the orangish browns and the whites as we get to the highest elevations here. So this is just combining color as hypsometric tinting with these Hachures in order to give a 3D effect.